How do hydrologists compare the yield of a tiny headwater stream to a massive river basin? The answer is magnitude-based hydrological signatures, which are among the simplest yet most fundamental descriptors of catchment behavior. In this video, we will explore the three most widely used magnitude-based hydrological signatures: mean annual runoff, specific runoff, and volumetric runoff coefficient, and discuss their strengths, limitations, and applications in hydrological modeling. Stay with me. Magnitude-based hydrological signatures provide a baseline measure of a catchment's water yield over a specific period, serving as the foundation for assessing water availability, ecosystem health, and catchment water balances. Unlike variability or peak flow signatures, which describe the temporal behavior of a stream flow, magnitude-based signatures focus on the total water yield. Because of their simplicity and strong physical interpretation, they are among the most commonly reported hydrological signatures in hydrology and water resources engineering. The major magnitude-based signatures are as follows. First, mean annual runoff, often abbreviated as MAR. To calculate it, we first compute the annual runoff for each year by summing the mean daily flows for all days in that year. Then we take arithmetic mean of those annual runoff values across all years of available data. The required data is a continuous discharge record spanning multiple complete years. MAR provides a direct measure of long-term water availability and forms the basis for many other hydrological indicators. However, MAR provides no information about variability, seasonality, or flood behavior. Two catchments with the same mean annual runoff may exhibit completely different streamflow regimes. It is also sensitive to the selected period of record, particularly under non-stationary climate conditions. The second indicator is a specific runoff, sometimes called a specific discharge. Instead of expressing streamflow as an absolute quantity, specific runoff normalizes discharge by the contributing catchment area. This simple normalization allows meaningful comparison between catchments of different sizes. Specific runoff is commonly expressed in millimeters per day or per year, making it directly comparable to precipitation and evapotranspiration. Its main limitation is its sensitivity to uncertainty in catchment area estimation. Also note that the true hydrologically contributing area can differ from topographic catchment boundary, especially in highly permeable or heavily managed catchments. The third indicator is the volumetric runoff coefficient. It is defined as the ratio of the total runoff depth to the total precipitation depth in a catchment over the same period of time. This signature indicates what proportion of rainfall ultimately becomes a streamflow. It is directly linked to the catchment water balance and is particularly valuable for understanding long-term catchment behavior. To calculate it, concurrent precipitation and discharge records over the same period are needed. Its limitation is that it says nothing about the timing of runoff. Two catchments can have identical runoff coefficients while producing completely different hydrographs. Overall, magnitude-based signatures offer several important advantages. They are simple to calculate, physically meaningful, computationally inexpensive, and directly grounded in the catchment water balance. They have also been reported extensively in national hydrological databases, making them ideal for comparing catchments across regions. However, they have also important limitations. They are affected by uncertainties in rainfall, streamflow, and catchment area estimates. Human activities such as reservoirs, abstractions, and land use change can alter these signatures significantly. More importantly, magnitude alone cannot distinguish between different runoff generation processes. That's why magnitude-based signatures should always be interpreted alongside variability and regime signatures. Magnitude-based signatures have a wide range of applications in hydrological modeling. Let's know more about them. They support catchment classification and prediction in ungauged basins where hydrologically similar watersheds are identified based on shared characteristics. They are widely used for model calibration and diagnostic evaluation, allowing engineers to assess whether simulated runoff volumes match observations. They also play an important role in large sample hydrology, machine learning applications, climate change impact assessment, and water resources planning. Magnitude-based hydrological signatures provide a concise and physically meaningful description of catchment yield. However, remember that they only quantify the amount of runoff, but not its timing, variability, or response dynamics. In the next episode of this series, we will explore the variability-based hydrological signatures, which reveal how stream flow changes through time and provide another important perspective on catchment behavior. Thank you for watching. See you in the next one.